In this video, we're going to discuss about polymorphism. We're going to try to define that concept. It's another one of the central concept in object-oriented programming, and it's one that is very, very closely linked to inheritance. So let's start this presentation. So definition of polymorphism. This is the ability for different types of objects to feature their own version of a method. So what defines a method, keep that in mind, okay? This is the name of the method, the return type, if there is any, if this is not void, okay? And the list of parameters, which means the name of the parameters, the order in which they are presented, the data type of each parameter. Okay, so that's what identify a method. Now, two methods can have the same name but different return value in the same parameter list. They are different methods. Okay, so the ability for different type of object to feature their own version of a method which behave differently. So we want to be able to, like, let's look at this example right down there directly, okay? We want to be able to say that if I have an object referenced to by a variable, let's say O, we want to be able to do different tasks calling the same method. So what this slide illustrates here in the second half is, I would say, the old way, the non-proper way to do that. I could say that I'm going to look at the type, the data type, the class name pretty much of my object. And based on that, I'm going to decide, well, if this object is of type employee, then I call the work method. And if this object is of type lawyer, then I call the sue method. And if this object is of class secretary, I call the report method, okay? But that's kind of cumbersome. And as you add more and more subclasses to employee, you have to go everywhere where you do that kind of those kind of shenanigans, and you have to edit your switch. So this is really not compliant with the dry DRY principle. Don't repeat yourself. That leads to a lot of redundant code that is hard to maintain, okay? So instead, what we would like to do is we want a single method, work. So the work method from employee, we are going to also implement it in lawyer instead of sue. We are going to also implement it in secretary instead of report. So we want the same method so that no matter what, we can call o.work. And then instead of having to test, you know, for differences in the code that is using actually the class employee, lawyer, and secretary, we are just going to delegate to the object itself to implement pretty much the right method. Okay, the right version of the method work. So we have one version of work implemented in employee, and we are going to have lawyer and secretary implement their own version of work and override the work method from their superclass employee. So let's take a look at this. Couple of rules to work with polymorphism. So let's say that we have a variable of type t. So this variable is meant to hold a reference to an object of type t. So for example, here the variable ed is supposed to be able to hold a reference to an object of type employee, of class employee, okay? Well, if it can hold a reference to an object of class employee, it can also hold a reference to any object of a class that happens to be a subclass of employee. So in our case, that means that we could create an object of class lawyer or secretary or even legal secretary, to use the inheritance hierarchy that we discussed a few videos ago. And we can create any of those objects and put a reference to those objects into the variable ed, which allows us to write code that expects to work on a reference to employee, but in fact, the reference that is given to us might be a reference to an object of class employee, or a reference to an object of class lawyer, an object of class secretary, legal secretary, marketer, whatever, okay? So any of the subclass, direct subclass, or, you know, subclass by transitivity, like for example, the employee superclass had a subclass named secretary, which had itself a subclass named legal secretary, okay? Well, if that's the case, then we can pass an object of class secretary or legal secretary and assign its reference to ed. They are still subclass of employee, okay? Now, what can you do when you have a reference like the one that we store in ed? Well, this is where, I mean, this first mechanism, this permission to assign, any reference to subclass object is what enables polymorphism. And then this rule is what really defines what you can do with it. If you have a variable meant to hold a reference to the class employee, well, you can call any method from the employee class on the object referred to by the reference inside of head. Okay, and the beauty of it is that if you have inside your subclass overridden any method from the superclass, like for example, we're talking about overriding, get salary, get vacation form in our previous videos, then automatically when you call one of those methods that are originally defined in the employee superclass, you call them on an object that is from a subclass of employee, and this object reference has been stored in head that is meant to hold a reference of type employee. Everything works as you would expect it to work. Okay? All right, so let's take an example here. Polymorphic parameters. So let's look at the code. Let's say we have a public static void main. Okay, we have Lisa, which is a variable meant to hold a reference to an object of class lawyer. And here, there's no polymorphism, okay? Lisa is meant to hold a reference to an object of class lawyer. We create such an object, and we put its reference in Lisa. So nothing, fancy going on here. Then we have secretary Steve. So Steve is a variable meant to hold a reference to an object of class secretary. Guess what? We create such an object, we put a reference in Steve. And then we call this method printinfo that we're going to write in a second. And we call it with Lisa, which is a lawyer, and Steve, which is a secretary. So if we would have written the printinfo method so that it accepts only a lawyer or only a secretary, we could not use the same method for both objects. But what we did instead, and this is where the polymorphic parameters come into play, we said that the parameter of that method was to be a reference to an object of class employee. And therefore, by polymorphism, this parameter here, E, can hold a reference to an object of class employee or reference to any subclass of that superclass. So that means lawyer is a subclass of employee, secretary is a subclass of employee. So that's why it works, okay? So we accept anything that is an employee or a specialized, pretty much, subclass of employee. And we can inside this method, because E is defined as a parameter of type reference to an object of class employee, we can call any method that has been defined in the class employee. And if it so happened that the subclass overrode that method, then the version that will be invoked automatically for us is going to be the overridden version. So again, works as expected. So if we are displaying here some information like this for different objects, well, for Lisa, for example, here's the pay, here's the vacation days, the color of the vacation form, and you can see that for Steve is going to be different values here that are displayed, values that are proper to a secretary as compared to a lawyer. So different number of vacation day, different color of vacation form, but all of this happened with the same method. So we have a method that now can intelligently handle different type of employee. And even more interesting, we don't have any code inside this method that's going to do the equivalent of that ugly switch that we had a few slides ago that's going to test to see what employee is about. We do not do that. As client of the class employee and its subclasses, we really let the polymorphic mechanism automatically for us determine which version of those methods defined in employee have to be called. Okay, and that's the great advantage of polymorphic parameters. Let's talk a little bit now about polymorphism and arrays. So arrays of a superclass type can store any subtype as elements. So let's take a look at what it means. Okay, let's say I have a main method. Inside this main method, I have E, which is a variable meant to hold a reference to an object of class array of employee objects. Okay, so array of references actually. Inside this array of employee object, I'm going to store 4 new objects. So this curly brace here and here, these curly brace are a way to say I want Java to create for me a new array object and populate it with 1, 2, 3, 4 objects. And the way I get those 1, 2, 3, 4 objects is I create them on the fly. Okay, so each statement, new lawyer parentheses, new secretary parentheses, and so on and so forth, new legal secretary parentheses is going to return a reference to a newly created object that is going to be put into this array. And then what I'm going to do, very simple, I'm going to write a loop. This loop is going to iterate on all the elements of that array E, and it's going to display on the screen the pay, the salary for that object, and the number of vacation days, and that's it. Okay, so one less than before. Then go to the next line and keep on doing that for every object in that array. So the output we're going to get is going to be something like that. So it's side by side, but you know, everything should be one below the other. So here's the first object, second object, third, fourth. Okay, so we have an array of objects pretty much right now. But the interesting thing is that this array was meant to contain employee object, right, the superclass. But what we use really are object of the subclasses of employee. Either a direct subclass like lawyer, secretary, marketer, or even indirect subclass like one level below like legal secretary. And there's no limit. If legal secretary had a subclass called, I don't know, specialized legal secretary, then we could also put object of that subclass into E, because E accepts any employee and any of the subclass, direct or not, of employee. Okay, so before we go any further, let's open a side note here, okay, and we are going to take a quick look at what this program would look like in memory if we draw the memory model, okay? The idea here is that, again, I want to make sure that I catch any misconception that you might have about references and arrays and reference being combined together, okay? So this is just a quick interlude here to make sure everybody is avoiding that misconception. So here's the first possibility, okay? E here is an array that contains 1, 2, 3, 4 objects, all right? That's not quite how it works, okay? I'm putting this here because this is a common mistake, a common misconception. That's not at all how things are represented in memory, okay? Remember, I told you that arrays are like objects, data types, right? So E is actually a reference variable that holds a reference to an object of class array of employee. So this view of everything is inside of the variable E, completely wrong. So we do have E as a reference variable, so it contains a reference, and here's our array object, and inside of the array object I have all of the other objects that are shoved in there. Is this one better? Not really. There's still another misconception here. Your array object does not contain directly the other objects, you know, that are in its cells, in its location in there, okay? Actually, it contains references to those objects. So this one is a bad view of what's happening in memory again. Let's go to the third and last one. And yes, this one, everybody should be comfortable with it because it's actually the correct representation. So let's sum up. E is a reference variable, contains a reference to an object of class array of employee. This is the object of class array of employee. That just means it's an array object that contains a bunch of references to employee object, but the employee objects are outside. So in this case, the reference that we have actually stored in the array are the first one is a reference to a lawyer object, which is okay by polymorphism. The second one is a reference to a secretary object, again okay because of polymorphism. Then a marketer object, then a legal secretary object, again okay because of polymorphism. Okay, so that was just a side note. Actually, it kind of interrupted the flow of the presentation, but I just wanted to make sure that everybody has a correct view of what's happening in memory when we start messing around with arrays that are supposed to contain object. Arrays contain reference to object. Okay. Now back on track. So far we used superclass methods on the variable head, right? So that's one thing that I've been kind of repeating, insisting on, is when we have a reference on employee stored inside of head, we can use everything that you would expect to be able to use from an object of class employee. And it just so happened that subclasses all of them inherit all the method of employee, so all those methods are there, and it just so happens that some of the subclasses are going to overwrite those methods, thus providing you with the peculiar behavior, the peculiar change of behavior for a method from employee that is required in one of the subclasses. Okay. Now, let's take a look at this example here. Let's say that we have, again, that head variable, same data type, reference to an object of class employee. And this time we create a new lawyer, okay, and we put the reference in head. So far, so good. Then we call a method. Let's say that we have a method in employee called getHours. It's going to tell us, I guess, how many hours that particular employee works in a week. We can call that on head, store it in hours, okay? But let's say that we try to call on head a method that has been added to the subclass lawyer, okay? A method that does not exist in the superclass employee, that has simply been written inside the subclass lawyer. And now we're trying to say to the object that is pointed to by head, that is referenced to by the variable head, I want to use this lawyer method. Well, it's not going to work. The compiler is going to provide you with an error. And the logic of it is that when you defined head, you said that it was meant to hold a reference to an object of class employee. So whenever you try to call a method, the Java compiler is going to make sure that you are actually calling a method that is available to any object of class employee. And this one, by definition, is not, because this is a new method that was only introduced in the class lawyer. The paradox is that head is defined as a reference to employee, but we know that we put actually the reference to an object of class lawyer inside of it. So it would make sense that we would allow, to use those methods on the object that is referenced to by head, but that's not going to happen because we have employee right here, okay? So it's kind of an interesting scenario here. Now, what about using the subclass method? Okay, so to use lawyer methods on head, we can typecast it. So typecasting is converting, the data type of a variable, of the value inside a variable actually, to another data type. So we can do that with primitive data types to a certain extent, right? We can do that with also reference values that are stored inside of variables like head. So let's keep this code here. We still have this code right up there, okay? But we are going to do something in addition to that, okay? We are going to define a variable called the real head. And this one is meant to hold a reference to an object of class lawyer. And we assign to it the same reference that was in head, but we convert it to a reference to an object of class lawyer. This is working only because inside of head we have indeed a reference to an object of class lawyer, okay? We're going to talk more about that, but you cannot magically convert, objects that are like lawyers into secretaries and so on and so forth. There are rules, okay? But here, because inside of head we had a reference to an object lawyer, and we were just prevented from calling the method of class lawyer because head was defined as it should be a reference to an employee. Well, now what we are saying is, okay, let's have a variable that is actually capable to hold a reference to a lawyer, and let's put that reference that we have in head into it, converting it on the fly to mark it as this is indeed really a reference to a lawyer type of object. And then we can do the real head.to, no problem. There's a shorter version of that. If we don't want to use extra variable, we could just take the value in head, cast it into a reference of type lawyer, then put extra parentheses here and say, I call the su method on that casted reference here. Okay, so both versions would work. This one use an extra variable, not a big deal. If that makes your program more readable, go for it. I mean, no problem. But the idea is the same. Okay. Couple of things to be careful about for. You cannot cast an object too far down the tree. So what do I mean by that? Okay, let's take an example here. A variable Eric meant to hold a reference to an object of class employee. So this is like our E in the previous slides, okay? create a new object of type secretary, put the reference in it. So that's okay because secretary is a subclass of employee, no problem. And I use this trick that I just learned, okay? I cast the reference inside Eric, which is supposed to be employee, into secretary, which is okay because Eric really has a reference to secretary. And I call a method, let's say that we have a method take dictation that is specific to the class secretary. So that works, okay? This is what we just covered. But then what if I try to cast the reference inside the method Eric to a legal secretary? So remember, we have the employee class, which is a superclass. The subclass of employee, one of the subclass is secretary. And then legal secretary is a subclass of secretary. And then I try to call a method that has been solely defined inside the class legal secretary. Well, that's not going to work. Okay, that's where I told you you cannot use casting like that, typecasting, to transform object. Okay, the only reason it works here is because Eric is indeed a reference to a secretary object, but it's not a reference to a legal secretary. So even if I apply this cast to the reference, when I finally follow the reference and try to find this method, I'm not going to find this method in the object that is being referred to. Okay, that's what's going to cause the problem. Another thing to keep in mind is you can cast up and down the hierarchy, you know, the inheritance tree, but not sideways. For example, Linda is a variable that's meant to hold a reference to an object of class lawyer. I create a new such object and I put the reference in Linda. Everything works so far. And then I try to use a magic trick, quote unquote, of typecasting to convert that reference inside Linda, which is a reference to a lawyer, to a reference to a secretary. And then I try to call a method that is, you know, particular to the secretary class. That's not going to work. Okay, there's no way to magically convert an object of class lawyer to an object of class secretary. It's just not going to work. Okay, so you can convert up and down the inheritance tree, but not sideways, like two classes that are, you know, subclasses of the same superclass or sibling classes, if you want to call them. That you cannot convert from one another this way. Third thing to keep in mind, casting doesn't actually change the object's behavior. It just allows the code to compile. So it tells pretty much Java, listen, I know what I'm doing, okay? And it should work, and you are going to let it work, okay? Remember that originally, the reason for which we could not call the method we wanted to call on the variable e is because the variable e was labeled as a reference to employee, just like Eric here, and it had inside of it a much more specialized object, a subclass of employee. So that's why it was working. But here in this case, for example, if we take Linda, okay, and so Linda is a reference to an object of class lawyer, and it's meant to hold a reference to object of class lawyer. If I cast it to an employee reference and call get vacation form, I'm still going to get the vacation form, the get vacation form method that was implemented inside the lawyer class to execute. So the form color that I'm going to get because Linda is a lawyer is going to be pink, okay? So Linda is a reference to an object of class lawyer. So when I call get vacation form, it is not the get vacation form method implemented in employee that's going to be triggered, even if I put this casting here to employee. Okay? Let's look at a little quiz question / exercise, you know, something that could show up in a little quiz that illustrate this, okay? So we're going more abstract here. We're not doing employees and secretaries and stuff like that. We're just saying, okay, I have a class A, can be whatever. Inside of it, a method f that just returns a string. And in this case, it returns a string that is uppercase A. Then I have a class B. So they might be in the same file here because only one of them is public. That class B extends A. So A is a superclass, B is a subclass. And I have the same method f, so I'm overriding the method f from the class A. And it returns B. So, you know, the method from class A returns A, the method from class B returns B. Okay, easy to follow. And then I have a static void main method here. So this is where execution of my program starts. Here's a variable B, meant to hold a reference to an object of class B. A variable A, meant to hold a reference to an object of class A. So easy to follow, okay? Inside of B, I put the reference of a newly created object of class B. So it's meant to have a reference to an object of class B. I put the reference to an object of class B. No trick there. But here comes the trick. In A, I assign the reference value that is in B converted to A. Okay? A is a superclass, B is a subclass. So I can do that. And then I do system.out println A dot, I call the method F, on the object referenced to by A. So what's displayed? Well, when you have this kind of problem to solve, you need to make a quick diagram, okay? And you need to keep track of what the objects are. The only object that has been created here is an instance of the class B, which I put into a reference variable, okay? And then I try to convert that reference into class A, which is a superclass of B. Great, that's exactly the same problem that we had on the previous slide, okay? Yes, I converted the reference, but at the end of the day, you know, I can call F on A because A is a reference to an object of class A, and the class A contains the method F, so that's check, okay, that works. But when I execute the method F, the method that is actually available inside the object, because this is an object of class B, is this one, okay? That's the method that has been overridden in class B. All right. So once you understand that, you will be able to infer, you know, that what is being displayed here is B because this is a version that is being executed. So make sure that you spend some time thinking about this. This is an example, by the way, that came from Stack Overflow. So you can find a lot of examples like that. Challenge is, you know, to try to test your understanding of the situation, but make sure that you take enough time to actually think about what polymorphism does, what it can do for you, what it cannot do for you. Don't hesitate to implement simple programs like this one. Okay, you don't need to do anything fancy. Two classes, one extends the other, and then try to play with conversion polymorphism. And as you bump into issue, don't hesitate to bring those Java files, you know, that you are playing with, and the questions about why they behave that way or why they do not behave the way you expected to the forum, okay, or the TA or the office hour. Okay, this is how you're going to really wrap your mind around how polymorphism is working, is by playing with it.